Happy Earth Day and welcome to the PPA 101 webinar sponsored by Penn Sustainability. My name is Natalie Walker and I'm the Sustainability Manager with Penn's Sustainability Office, located in the Division of Facilities and Real Estate Services. On April 13th, the University of Pennsylvania announced the signing of a power purchase agreement, the creation of the largest solar power purchase project in Pennsylvania. Today, Andrew Nyholm, a graduating senior at Penn in Physics and Material Science and Engineering, will moderate a discussion with three panelists covering an overview of power purchase agreements, Penn's power purchase agreement, and the solar development process. This event is being recorded. All attendees will be muted for the duration of the forum. Please type any questions that you have for the panelists into the Q&A box. Andrew Nyholm will relay all questions to the presenters after we have heard from all three panelists. If we're unable to answer all questions during our presentation today, we will provide responses on our website. With that, I'll turn it over to Andrew Nyholm to introduce our first panelist.
Hello, everyone. I'm very excited to talk to you all today. Today is the 50th Earth Day, so it's very exciting to talk about something that Penn is doing that is great for the sustainability of the campus. As Natalie says, I'm a senior at Penn. So it's bittersweet to be doing this virtually, but I'm very excited about the material we'll be covering. And our first speaker, I'm very excited to introduce Dr. Huemmler. He is a senior lecturer in the School of Engineering, and he will go over power purchase agreements as an overview of the topic itself. Dr. Huemmler?
Great. Thanks for having me on the panel today. This is a great way to celebrate Earth Day. I was there 50 years ago. I've still got the pin, and it's just amazing that 50 years later, some of the hopes of that first Earth Day are coming true. Solar has become economic, and Penn's deal demonstrates it can play a significant role in our energy future. I'd like to congratulate the energy team and facilities for pulling this all together. It's been a long time in coming, but as we'll see in a moment, what I want to take you through is that these deals are pretty complex. They require a lot of analysis. The contractual arrangements take time to work through. And the approval process for a buyer that's buying something big for the first time, that's complicated, that takes a lot of effort and thought. But make no mistake, this is a big deal. 220 megawatts is the largest solar deal done by any academic institution. And it's in the same league as some recent deals done by big corporate players. Google's recently signed contracts for 720 megawatts from solar farms in North Carolina, South Carolina, and Texas. That would be in a 490 megawatt deal. Amazon has got 3 new projects going, totaling 175 megawatts. Facebook 100, Toyota 75. And for those of you that are coping with stress by drinking beer, which is not recommended, Budweiser is behind a 130 megawatt project. So Penn is right up there with some of the biggest solar deals that are being done right now. To understand how this works, I want to walk through a few basic concepts about the grid and then talk about what's in a power purchase agreement. First, when you inject electricity into the grid from any generating facility, you don't get the same electricity out of the grid on the other side of the grid. Electricity follows a path of least resistance. It goes to where it wants to go. So in the past, to become green, buyers would buy renewable energy credits from wind and solar generators. Some of them might be far away, not directly connected to the grid that's supplying your power. The buyer would apply these renewable energy credits to their purchases off the grid, and that would be considered green power. Strangely enough, the power leaving the solar facility is no longer considered green because you sold that attribute to another party. The beauty of the Penn deal and these other large deals that are happening is that solar, the electricity itself, has become economic. A few reasons for this. The panels have become much more efficient. The manufacturing costs have come down. And developers have learned how to put these deals together, as we will see. So Penn is buying a bundled product now from these two new solar fields. And those three products are energy, capacity, and renewable energy credits. They're actually renewable energy certificates, but they're commonly known as RECs. I'm going to walk through what those products are. Well, first off, let's go to the next slide. First off, energy is energy. That's the electricity that you're looking for. But capacity is another important concept. The way to think about capacity is you want the power pool to supply power at times of peak demand. You really want the electricity to come on for your air conditioner on the hottest day of the summer. And to do that, you have to have a power plant there. And power plants that run very rarely just don't make that much money. So the power pool has to pay these plants just to be there on the hottest day of the year. There are many power plants that rarely run, that make more money from capacity payments than they do from energy payments. Customers pay a capacity charge based upon their peak demand during the hottest days of the summer. Customers have to buy capacity. Residential customers don't see that charge in their bill. It's buried in with everything else, but commercial, industrial, institutional customers do see a capacity charge. They need to buy capacity. A solar facility, a wind facility provides capacity. Although that capacity that comes out of a solar plant doesn't get full value, solar is discounted to 42%, wind even less, to 12%. And, the way to think about wind is think of a hot, humid day where there might be a system peak, and there's usually little breeze on that hot, humid day. So wind, for instance, can't be counted on to supply the full amount of capacity that the plant would provide at peak. Okay, next slide. The next product that a solar or renewable facility produces are renewable energy credits. Basically, if 1 megawatt hour comes out of a renewable plant, it gets 1 REC. If 1 megawatt hour from a solar facility is generated, it gets an SREC. Many states require a certain percentage of retail electric sales to have to come from renewable sources. Some states have specific provisions for solar. And there is a demand, since there's the demand for these RECs, not only because the government wants them, also customers want them. They have a marketplace value. So what's happened with this is developers have bundled all three of these products together, again, energy, capacity, and renewable energy credits, into deals that are cost competitive and very affordable going forward. Let's walk into what this power purchase agreement looks like, the elements of the power purchase agreement. Okay, some of these are pretty straightforward. Some of them require a lot of thought. Very simply, at the beginning of the contract, you want to identify who the seller and the buyer is. The next part is very important. You want to very carefully define what every term in the contract means. You don't want any confusion about that. You want the deal to be done in accordance with the rules set by the Federal Energy Regulatory Commission, the independent system operator, the regional transmission organization, and you want to comply with state rules and regulations. You want to define what the product is. I just mentioned three: energy, that's your basic electricity; capacity, the ability to be there when a plant's called upon; and renewable energy certificates. You want to be clear about how many megawatt hours you're going to receive, how many megawatts of capacity are going to be there, when it's going to be supplied. And developers run very, very sophisticated programs to figure out how much electricity is going to be generated by a solar facility. They take a very careful look at historic sunshine records, historic weather records to figure out how much they can produce. Pricing can come in a variety of different ways. You can make it really complicated. Typically, Customers like Penn, or let's say a municipal utility out there, they want very simple pricing. Typically, it's dollars per megawatt hour delivered. That's the best way to do it. The other thing that you want to do in a PPA contract is you want to have set prices. You want the pricing to be fixed for the length of the contract. You could index it to the price of natural gas. That's not relevant in this case. One of the things that you're able to do with solar is, since you know what the cost structure is for solar for the life of the facility, you have no fuel cost, you know what your maintenance costs are. It's basically cleaning off the panels every once in a while. You can construct a price that is known for a long time. And that's a real attractive feature for solar. How long the contract's going to last? Typically, they last for the life of the facility. And solar panels come with a 25-year warranty from a manufacturer. So it's not unusual to have these long-term contracts, again, because you know what the price is for the length of that contract. Okay, flipping over to the next one. Okay, you want to be clear about where the delivery point is. It does cost money to use the transmission system. Buyers don't want to get involved in paying that cost. It gets complicated when there's congestion on the system. So you want the electricity to be delivered where it's going to be used. You want to be very clear how it's metered. You want to be clear as to who is responsible for scheduling the output of the power plant at the power pool. You want to be very clear about how the billing is going to be done, how payments are going to be made. Back office operations are important because that's where the money comes in. Creditworthiness, another key consideration. You clearly want the buyer to be creditworthy. An institution like Penn, definitely a creditworthy buyer going forward. Sellers in markets like this are just love customers like Penn because they know it's going to be around for a while. Conversely, you want to consider the creditworthiness of the seller, and the reason you want to think about that is if the seller fails to produce, if the seller fails to provide electricity, then the buyer's going to have to go out and buy replacement electricity, or actually the seller's going to have to go out and buy electricity to replace what wasn't provided. And you want to make sure that the seller has the credit, has the ability to financially go out and buy replacement power. Another contract element in this one people spend a lot of time with, and that is if something goes wrong, if there's an unexpected event, which party bears the consequences of that? Which party pays for that? And you have to think through a lot of different things. What could happen? What could happen? What could happen? If a tornado comes through the solar facility, who's responsible for that? Who pays the cost of that? In most cases, in almost all cases, the buyer doesn't want to take on any of these risks at all. They typically don't. All of the risk are assigned to the supplier who's operating the plant. So there's very little, near zero, I would say zero operational risk that a buyer will take on. Okay, closing out. Because there's one more thing here that's an important part of the contract. You have to identify what remedies are if the power is not supplied, if the project doesn't come in on time, if there's a failure to schedule the plant with the grid operator. And penalties are usually in the form of liquidated damage. That is the costs that are incurred by the buyer to replace the power. Those costs are paid by the seller. There are other provisions in a contract which may apply that release the seller from certain obligations. These are called force majeure provisions, and they can include war, pandemics, I had to throw that in there, and acts of God. Those can all be subjects of debate, as can other contract terms. And the last thing that you want in a contract is governing law. That is, if the parties do end up in court, again, you can have a debate over what an act of God is. You can have a debate over what a specific contract term is. You want to know which state you're going to end up in that governs this dispute. And then finally, once you succeed in figuring this all out, and again, you can see the complexity of these deals. Once the power purchase agreement, these things are also known as offtake agreements. Once that deal is signed, the developer can take the project to the bank and get financing. Banks aren't going to lend you money unless they know how they're going to get their money back. And since the developer has now signed the deal with a creditworthy buyer, the bank knows that there's a revenue stream that's going to extend long into the future. And they're very happy to lend the project money. And with that money, the developer can finalize site control. They can go out and start procuring panels and equipment, and they can commence construction and tie it into the grid. So that's the process. That's what's been accomplished, and it's tremendous that it's happened. So I'll follow up with questions later in the day.
Thank you, Dr. Huemmler, for that great overview of power purchase agreements. Now, our next speaker is Ben Suplick, who is our Director of Engineering and Energy Planning of the University of Pennsylvania, and he will talk about our Penn purchase power agreement. Sorry about that. Ben, take it away.
Thank you. Yeah, the alliteration is a little hard sometimes. I'm very, very proud of this achievement. It's been about 3 years in the making. And I'm going to try and give everybody who's online a flavor for what it took for us to go from where we were to where we are now. Obviously, when you're doing a project like this, you need to have clear objectives as to what you're trying to achieve. And for us, there were two main ones to start. Minimizing carbon emissions is one of the things that Dr. Gutman, our president, has made as one of her most important goals. And so minimizing those through the use of renewable energy was a big part of this, obviously. But we wanted to do it, or needed to do it, in a way that was not going to put the university at risk financially. And so obtaining pricing that's competitive to what we call spot market prices was one of the goals that drove us forward with it. We also wanted to establish a fixed cost for electricity as a long-term hedge. If you look at pricing for electricity on the market, it can fluctuate up to 10 times values over the course of a summer, and that variation can play havoc with our ability to budget and plan for utility expenditures. So the ability to buy a product that gives us a fixed or known price for electricity over 25 years is extremely helpful and beneficial to the university, and one of the things that we were including in our objectives. And lastly, as Andy mentioned, we could have been buying RECs. We bought RECs in the past, renewable energy credits, from locations throughout the country. But for this project, we wanted something located in the local community area. We wanted something that would affect the PJM grid, which provides us with electricity. We wanted something that would potentially replace or offset a fossil fuel plant from coming online. And so by being in the PJM grid, we felt that would be, a goal that was really necessary for us to proceed further. Next. So the question's been raised, why now? Renewable energy has been an option for years. We actually looked at it fairly seriously 7-8 years ago. And some of the things that have changed in the market are that the climate action plan that Penn has put forth most recently in 2019 has included renewable energy as one of the tools that will get us to our ultimate goal of carbon neutrality. We also wanted to address the need for meeting the Paris Accords. Penn is very sensitive to how the carbon emissions from its facilities affects the climate, and we needed to make steps towards addressing that. We also noticed that renewable energy costs have declined significantly and have become competitive with fossil fuel plant prices. So the cost premium that we would be paying had started to evaporate, and we wanted to see if we could take advantage of that. We also were aware that there was a federal investment tax credit for renewable energy, both wind and solar having separate programs. And we also saw that those programs were starting to expire. So we felt moving now would give us the opportunity to have those benefits impact the price we would pay. We also looked at the PJM grid and what projects were being planned. And we saw that there were a number of solar projects, and as well as wind, but more solar projects in the queue to be developed. And we felt this would give us an opportunity to get competitive pricing from the number of projects that were being planned. And lastly, as I mentioned earlier, we felt that, in looking at other hedge opportunities, financial hedges, that this would be a much more cost-effective way for us to effectively hedge our utility costs and give the university some price reliability. So as I mentioned earlier, the carbon emissions impact is probably the biggest aspect of this. And we are estimating that this project will reduce carbon emissions by 166,000 metric tons of carbon. That is spread across both the university and the health system, as well as a few of our other facilities. If you look at the Climate Action Plan 3.0, which was issued last year, there's a waterfall chart that has been developed that identifies the different tools that we will be using going from 2019 to 2024 in reducing our carbon emissions. And click one more. In the center of this circle is the emission reduction that we're attributing to the use of solar or renewable energy on campus. And as you can see, by procuring renewable energy, we were expecting in our plan to be able to reduce carbon emissions for the university by almost 24%. One more. We're waiting for a click. Well, the other aspect is the Paris Accords. By implementing this project now, we are expecting that by 2023, the university will have achieved the goals of the Paris Accords, and that will put us 7 years ahead of the goal for carbon reduction. Next. So the question has also been raised as to why we have procured solar power versus wind power. We had previously purchased wind RECs for, I believe it was at least 10 years to offset our emissions from our electrical use. And why didn't we just continue to purchase, renewable energy produced by wind? There's a number of reasons for that. One is that the generation of solar power occurs during the peak pricing period, meaning that we could obtain a fixed price or a predictable price for our electricity during those periods. It also closely matches our electrical load. The solar power is produced at its greatest amount when Penn's electrical load is also its greatest. So the combination of those two gives us a beneficial price impact on our utility costs. Solar also offers a more effective reduction in carbon emissions, as the production peaking during the peak hours of the day is also when the grid is utilizing the most carbon-intensive generators. So by providing solar power during those peak periods, we're able to offset those fossil fuel plants from having to come online. As I mentioned previously, solar prices have declined and are very competitive now with spot market prices. In comparison, wind prices haven't declined as extensively, and so the cost for solar remains lower than wind. The investment tax credit is different for both solar and wind. The solar tax credit is starting to decline. It started in 2020 and will decline over the next few years. Meanwhile, the wind tax credits expired at the end of 2019. So it really did affect the pricing that we were seeing when we were investigating. And finally, as I mentioned earlier, there are a number of projects in the planning stages in the PJM grid. But if you look at the number of solar projects versus the number of wind projects, there's a vast majority of solar projects in comparison. And by having that many projects potential proposers for our needs, it gave us a very competitive pricing opportunity. Next. One aspect that is unique to Penn in comparison to other institutions and even industrial and commercial users is that we operate what's called a load-serving entity. And a load-serving entity is the PJM grid term for basically an electric utility. PECO is a load-serving entity, PP&L, and the other local suppliers, the people that you buy your electricity from at the residential level. They are all load-serving entities. By Penn setting up a load-serving entity to supply its campus electricity, we're able to deal directly with the grid. We're able to purchase our electricity on the wholesale market and directly benefit from spot market pricing. The other benefit is that we're able to enter into a power purchase agreement directly with the provider of electricity. We don't have to deal with a middleman or a utility. We're able to go directly out to the developers and speak with them ourselves. This allowed us to dictate what we wanted from this power purchase agreement when we went out for proposal. We had certain criteria that we wanted, and by being the direct negotiator and buyer, it gave us the power to dictate what we wanted. Now, the benefits of this model were several. One is that we were able to get a lower price because there is nobody in between us and the developer or the supplier. We're buying directly from them, so there's no markups, no middleman. We were able to vet the potential projects directly. We could ask any questions we wanted. We could get deep into what was being planned, where it was being planned, its effect on the local community, who the landowners were, all those sorts of details, which gave us much more confidence that we were getting a project that matched up with Penn's philosophies. And finally, our size allowed us to take on the full output of a project. As Dr. Huemmler mentioned, being able to deal with an entity that's able to buy the entire output of a plant that has good credit rating made the deal much easier and much more confident on the developer side that they knew what they were getting. And the complexity is that they didn't have to deal with multiple contracts or multiple off-takers. They dealt with one user, one off-taker, and that made the project much more simple and much more easy to negotiate. Next. So to give you a little flavor for what this process entailed, as I mentioned, it was about I was looking back at my emails recently, and I think the first communication I had about investigating this was in 2017. So the process that we followed was a fairly rational one. We first identified that there was an opportunity for the procurement of renewable energy as we saw prices declining. In order to help us, parse through the information and ensure that we were looking at this correctly, we selected a renewable energy consultant, Emerald Energy, who's led by Mike Freeman, to perform a financial analysis for us and determine whether renewable energy was something that made financial sense under a power purchase agreement model. As it turns out, there was a good opportunity for us to take advantage of it. So we presented those findings to Penn leadership, and they gave us the green light to proceed with an RFP to solicit renewable energy. We issued the RFP to about 38 developers and generators. We had vetted these select recipients of the RFP to ensure that they were projects or people that could produce a project that could be taken to the finish line. We didn't want to just go out and anyone who was proposing a project to solicit or to propose to us. We wanted to ensure that the people that proposed to us had the credibility and the capability to take this project through. Ultimately, we received 102 offers from 17 developers. And the reason we received so many offers is that even on one particular site, there are multiple contract terms that can be offered. Differences in price, differences in length of contract, differences in size of facility, differences in number of megawatt hours offered. And so each of these iterations produced a different proposal. So we went through all 102 and ranked them based on what our original criteria was, and narrowed it down with the help again with Emerald Energy. I keep mentioning our consultants because they were such help to us and really made this project move forward at a pace that was necessary. But we analyzed the projects and shortlisted developers. After we shortlisted, we did a deeper dive into those developers' capabilities, reliability, past experience, as well as vetting their cost proposals against what we thought was appropriate for Penn, and we selected Community Energy as the ultimate developer we wanted to work with. At that point, we needed to start working on the contract. Again, as Dr. Huemmler mentioned, the power purchase agreement contract is a complex and detailed legal document. So we engaged the law firm of Cozen O'Connor and their PPA specialist, Michael Connolly, who I can't say enough good things about, and how he helped us through this process and got us the product we wanted from a legal standpoint. Initially, we negotiated a term sheet that just set the basic tenets of the PPA: number of megawatts, number of megawatt hours, initial date of construction and operation. Those are the things that created a framework around which we built the ultimate power purchase agreement contract. And then we used those terms to get to the point where we are today. Next. To give you a sense for how long this took, it was fast. Let me tell you. We, as I mentioned, 3 years ago, we started looking at this. We finally got to the point of issuing the RFP less than a year ago, June 28th of 2019. Right before July 4th weekend, as I recall. We were wondering whether the July 4th holidays were going to impact our ability to get a number of proposals, but fortunately, most of the folks we talked to said it wasn't going to affect their ability to respond. So 4 weeks later, we received the 102 proposals that I mentioned, and then we dove in and started to go through them. Took us another 4 weeks to rank, evaluate, vet, and analyze those proposals, and end up with a short list. And that was at the end of August. And then we spent the next 2 weeks vetting that shortlisted group to determine who we were going to select. So on September 9th of 2019, we called up Community Energy and told them that they were our preferred vendor and to get ready. We needed to present our recommendation for this to the Board of Trustees. And the next Board of Trustee meeting wasn't until November 7th, 8th. So we prepared our presentation to them. But in the meantime, we knew that negotiating the power purchase agreement itself was going to take a significant amount of time. And so we began to negotiate with Community Energy on September 10th and proceeded to do that in parallel with our preparations for recommendations to the trustees. Fortunately, the trustees agreed with us and gave us the green light to proceed to consummating a deal ultimately with Community Energy. And that overall negotiation took us about 24 weeks or 6 months. And that may seem like a long period of time, but please look into that we also went through the holidays And if you look at other power purchase agreement terms, how long it took for other entities to get through a negotiated contract, we're at about half to a third of the amount of time that other entities have taken to get their power purchase agreement contracts completed. This was fast, and I have to give a lot of credit to our team that put this together and were able to get us to the finish line. So on February 28th, the agreement was signed. Lots of high fives and woohoos that day. And now we're in the process of communicating, discussing, and following with community energy as they proceed to getting us to commercial operation. Next. So let me wrap up with some of the lessons learned and recommendations for those of you out there that may be considering this for your own organizations. And this isn't in any particular, this is more an order of priority than an order of timeline. First and foremost, you really need to hire a trusted and experienced support team. As I mentioned, ours consisted of Emerald Energy and Cozen O'Connor. And without these two trusted entities, we wouldn't have been able to do this project to the level and in the time frame that we did. Second, you really need to do your homework. You can't even though you have a good team, you can't rely on them to do everything for you. You need to know what you want. You need to know how this works, and you need to know it as well, if not better than developers. There's going to be a lot of discussion about technical issues, and while you're going to learn along the way, your best to be bone up as best you can before that. Talk to peers, talk to people who have done this before. Attend webinars like this one. Read up on it. There's a lot of information out there, but your knowledge will only help you as you go through the process. And as I mentioned at the start, we had objectives that we had developed, and those came from the preliminary analysis we had done. And I really believe that it really will help you guide, it will really help guide you if you do that analysis up front so that you know where you're headed and what you want to get. It also helps that you know what you might get, so the two don't match up. You're not proceeding down the path of an RFP without knowing what your potential outcome might be. Fourth, you really need to engage all the stakeholders from your organization that this might have an impact on. Not just the operations and energy people. It includes the finance people, the budget people, the schools and centers for us who are going to be consuming this power. There's a number of individuals part in this, and we're all kept in the loop, and we're all on the same page as we proceeded. And that collaboration really led to part of the success, and much of the success that we're enjoying now. Fifth, and as I mentioned, prior to this, in number two and number one, you got to learn. You got to, even while you're going through the process, continue to learn. If you have a question, you got to become an expert on it. The more knowledge you have, the better off it will be for you in the long run. And lastly, you got to rely on your team. Not only do you have to hire a trusted team, but you need to rely on them. If if the answer that you're going to give is the same as the answer they're going to give, that is where you know that you're in sync. And having that level of trust will only result in a great outcome. So there, I think I'm going to stop and wait for questions at the end. Thank you.
All right. Thank you, Mr. Suplick. That was really informative. So the next speaker we have is Jay Carlis, who is the Executive Vice President of Community Energy, and he will go over the solar development itself. Thank you for joining us.
All right. Well, thank you, and thanks for having me as part of this webinar. It's a great honor to be working here with the University of Pennsylvania on this project. And where I wanted to start was just a little history. Not the first time that the University of Pennsylvania has made a real impact for new renewable energy development. Back in 2005, Community Energy was developing a farm in the Scranton area of Pennsylvania. had a energy only, but the economics were not enough to finance and construct that wind farm. So the University of Pennsylvania came along, signed a 10-year contract to purchase the renewable energy credits from the Bear Creek wind farm, and that was what enabled us to get the construction financing to build Bear Creek Wind Farm, which is one of the Pennsylvania's first, and is still operating outside of Scranton. Next slide, please. So, and what you see here is a picture of Pennsylvania's first utility-scale solar farm project that was originally developed by Community Energy. Started working on it in about 2009, and ultimately brought it to commercial operation in 2012. That's a long time ago now, and at that point in time, 5 megawatts was the largest solar project in the state. And now, of course, with the power purchase agreement in Pennsylvania, we're talking about a project that is 220 megawatts. So that is a very big leap forward in less than 10 years in terms of what will ultimately be the largest utility scale project in Pennsylvania, and one of the largest in the entire eastern. And if we go to the next slide, what you will see is an aerial image of another solar project that Community Energy developed, this one on the eastern shore of Virginia. Power purchase agreement for this project is with Amazon Web Services, a data center subsidiary of Amazon, a company we all know. And the reason why I'm showing you this picture is this gives you a sense of what this Great Cove project would look like from the air. You have little pods. Some might be as small as 5 megawatts. Some might be as big as 20 megawatts. But we're not talking about a 220 megawatt block of solar panels. It just is impossible to do anything like that in the eastern U.S. You've got topography, you've got wetlands, forested areas, conservation easements, and you've got some landowners who are not interested in participating. So you put all that together and have to have a project that's kind of spread out across a large area with little mini arrays that are all tied together through voltage cabling and connected to one point of interconnection on the grid. And if you go to the next slide, a little bit of detail about this project. You're talking about the Great Cove Solar project here with the power purchase agreement with Pennsylvania. It's actually 2 projects with 2 points of interconnection. One 70 megawatts, one 150 megawatts. And we're expecting to produce about 450,000 megawatt hours of electricity first year of generation. Solar panels degrade over time, and so they produce less time, but in the first year we're about 450,000 megawatt hours, and that is the equivalent to the electric use of more than 43,000 homes in Pennsylvania. The average Pennsylvania electric, based on average Pennsylvania electric use. And we're talking about 1,600 acres in central Pennsylvania. So that's a lot of land that it takes to build a project of this size. But what you can see from the picture is that we really are very minimally. We're not covering all the land. There's space between the rows to avoid shading. Those panels are single-axis trackers. They will move throughout the day, and so almost all of the land underneath panels and inside the 1,600 acres that we're talking about, almost all of it is really directly exposed to the sunlight, and we'll have green grass and a mix of plants growing underneath it that will return nutrients to the soil over time and make the soil more productive when we're finished than when we started. And we're expecting for this project to be operational. And next slide. I wanted to just talk a little bit more about the single axis tracker. I think this is an important aspect of the value of this project for the university and for the environment, for the grid, the electric grid. And it really is the way that these projects are being developed all around the world these days. Wherever single axis trackers. And so these are panels that are on a racking system that move throughout the day. They start facing midday. They're practically flat to the sky. And in the afternoon, they move towards the west. And go to the next slide, why this is so important. And this is a picture of the electric demand in the PJM grid on a summer afternoon. And you can see how the electric demand ramps up through the day. At noon, it isn't even peaking yet. It takes until almost 6 o'clock at night to get to the full peak of that demand. And the great thing about these single axis trackers, because we're moving with the sun, is that we are still producing, nearly peak output at 6 p.m. And we'll continue on, in the longest days of the year, July and August, we will continue to produce even till, 8 o'clock at night. And so there's a great benefit to the electric grid in terms of providing power when it's needed most. Grid operators pay for this value through capacity payments, and a single axis tracker is more valuable fixed tilt project being just is kind of built angled facing south, and the fixed tilt projects really do peak 12 and 1 o'clock, and then their production starts to wane. By 4 o'clock, even in the sunniest day of the year, you're hardly getting any production from a fixed tilt project. So that's a little bit about this specific project. I wanted to just take another few minutes and talk a little bit about solar development, what that is, and why this power purchase agreement with the University of Pennsylvania is so important. So if we go to the next slide, you can see we're talking about first step in solar project development is finding land that either somebody wants to sell, or more typically for our project in particular, that they want to lease. So, we'll sign a long-term lease, 35, 40-year lease with landowners. They get steady long-term income, and then once we have land, then file for an interconnection feasibility study with the PJM grid. And that study process takes anywhere from 2 to 3 years. So began developing this project long before we had conversations with the University of Pennsylvania or anybody else about buying the power. We had to make sure that we had a feasible project that could interconnect to the grid at a reasonable cost. Once you have that, then the next step is to go to the next slide. You get just a little picture of what some of these meetings are like, when you're going for permit approvals. There are a lot of different permits that can be required, and sometimes they're more administrative and are kind of pushing papers around between various agencies. Sometimes there's public hearings, but all can go through the land, the interconnect, and the permit, and you can have a project that's permitted and ready to build. In these days, in this environment, and even more so today in this challenging economic situation, we're not going to build a new solar project unless you have a contract to sell the power for a long-term period to a credit-worthy off-taker. And that's where the University of Pennsylvania comes in. So with this power purchase agreement, we are now able to take this project from the planning phase and the feasibility phase through final development and eventually to construction and operations. And that's an incredible benefit for the power grid and for the environment, and it's going to create a lot of economic development in central Pennsylvania as well, where this project is located. So it's a very exciting project. Very pleased to be a part of this with the University of Pennsylvania. And I'll stick around for your questions.
Thank you, Mr. Carlis, and thank you, everyone. Thank you, all our speakers, and thank you for all the attendees, and thank you for all the great questions. We'll now go through a couple of them. Please continue to submit questions as you may. If we run out of time, we will get back to you, or if you have questions afterwards, please feel free to contact us at any of these websites you can see up on our screen. Website, email, Facebook, Twitter, Instagram, we'll all route them together and collect answers for you. Now, I'm going to get started on the questions, and the first one is kind of directed towards Ben Suplick. Why is Penn not pursuing larger solar projects on Penn's campus?
That's a good question. We have looked at solar on campus. The challenge is that we're an urban university, and there's not enough area to really make an impactful result from putting solar panels up. I mean, if you look at the topography and aerial view of our campus, it's buildings with flat roofs. And we did a back of the envelope calculation a few years ago, and if we put solar panels on every flat area of roof that we could, I believe we ended up with about 3% of our load being supplied. So this is the power purchase agreement is really the only way that we can move the needle for Penn's electrical use to be supplied from renewable energy. We continue to look at whether there's opportunities for demonstration projects on campus, but to make a real impact, there's just not a feasible option.
Okay, thank you. So the next question is kind of directed towards Jay Carlis, if you want to join back on. Was an environmental impact assessment completed for the site of the PPA? What was found in this assessment, if it was completed?
Yeah, well, the environmental studies are ongoing. So far, we have not found anything of concern. And typically, on a project like this, and most of the projects that we developed have over 1,000 megawatts of projects that we developed, typically on marginal ends. We're not installing panels anywhere, cutting down some plots of trees, interacting with critical habitat. This is really farmland that's been tilled, so you don't really find a whole lot of environmental sensitive land.
Okay.
We don't expect to find it.
Well, let us know if you do.
Okay.
So another question, this one coming from Gina Marinelli, and I'm sorry if I pronounced your name wrong. Congratulations on the team's achievement. What would you say the lessons learned are regarding the communication strategy with various stakeholders? And I'll leave this to whatever speaker wants to go.
This is Ben Suplick. Let me put my camera there. I think I mentioned during my talk that that engaging stakeholders is an extremely important aspect. The communication needs to start up front. I guess I'm not clear on whether the questioner is asking the type, the frequency, or when we're talking about communication. There were a number of presentations that I had to give to stakeholders to educate them along the way. So this wasn't just a matter of letting them know that we're doing this, but it was a full-on educational process for the stakeholders in budget, in finance, operations. All of those entities needed to be brought up to speed on how the power grid works, what we were actually purchasing, and then the details and complexity of the agreement. So it wasn't a matter of a few select pieces of information. It was really an ongoing updating and answering questions and being available to those folks so that they were confident and comfortable with what we were doing.
Okay, thank you. So I believe we're going to fit this last question in. We'll follow up with all other questions. But this question in from Mary J. Marciano: is there any opportunity for this project to be used for engineering and data studies by UPenn studies? And this is interesting for me since I'm an engineer at Penn. So whatever speaker wants to take it, please answer away.
I'm going to jump in again. Although Jay obviously will have to be part of anything we do related to this, but that is something that we considered as part of our effort, how we can engage academic opportunity and even just the community in knowledge about the project as it goes forward. So we're still in preliminary design of the details of this. But there certainly is going to be opportunity for us to have discussions with students and academic on campus about what they might find to be beneficial and how that could be integrated into the project in a way that benefits them as well as benefiting us. So I'm not saying that we have a specific plan, but we are more than open to discussing what opportunities might be available.
All right, that sounds like a promising future. So unfortunately, we're reaching the end of our time here together. There are a number of great questions that I'm really excited to hear the answers of another time. So we'll follow up and answer all the questions through email or contacting you. But to conclude this, we have Natalie Walker, the Sustainability Manager of the Sustainability Office, to wrap up.
Okay.
Thank you.
Thank you all for taking the time to learn about power purchase agreements and Penn's commitment. I want to thank Andy Nyholm for moderating our discussion and leading us today. I also want to thank our speakers, Andy, Ben, and Jay, for taking the time to educate and empower us today. And I want to thank Community Energy for your partnership with this power purchase agreement. All of the stakeholders in the Division of Facilities and Real Estate Services, Office of Budget Management and Analysis, Division of Finance, and Office of General Counsel worked countless hours and many late nights to make this happen, so we want to make sure to thank you as well. This really is an amazing accomplishment that would not be possible without all of your support. So we've compiled a list of the unanswered questions, and we'll follow up with the responses within a few days. Thank you all for taking time to join us again today, and have a wonderful Earth Day.